Now, in this video, we're going to show you an example of how to apply the limit definition of the derivative to find the derivative of a function, which in this case is a square root function. It is not a polynomial. The polynomial ones are, they have a lot of terms. They can be a little messy. They require you to remember how to do all these polynomial things, but they're not as difficult as it is when it comes to square root problems or when it comes to rational functions, which we'll do in another video. And so I wanted to go through some of these examples because they require the square roots and the rational functions each require individual tricks that you need to apply. And so remembering to apply those tricks and not just getting stuck algebraically is half the battle, or maybe 90% of the battle, honestly. Okay, so we're going to use this function, the square root of x plus 4, and we're going to show that the derivative is 1 over 2 times the square root of x plus 4. All right, now, again, as I've done in the previous video, what I'm going to do is I'm going to start by building up the pieces of the function. But in this particular case, it actually doesn't do that much, make much difference, because there's not a lot of like algebra and simplification to do. There's only a single term here, and all the algebra and simplification is actually going to come after we do the putting the whole thing back together again. So let's just construct our next term. And let's put in our f of x plus h and our f of x. Now, remember that the x plus h goes into the function where the x is. So this is not the square root of x plus 4 plus h at the end. It's x plus h plus 4. And then our function is our square root of x plus 4. Now, this is where we sort of run into issues. There's no algebra to do at this point. We can't, it's not straightforward to combine these functions in the way that they're written. And there's no straightforward way to cancel the h. You certainly can't just cancel it with what the h is in the numerator and be done with it. That is not going to work. So what we have to do here is we have to actually apply a bit of a trick. And the trick is we have to apply a rationalization term. Now, we're not rationalizing the denominator, which is what we usually do when we rationalize expressions that involve square roots. We're actually going to rationalize the numerator because it's the numerator that we want to be simplified because we need to get an h out of it in order to cancel with the h in the denominator. And so we're going to rationalize the numerator, and we're going to do that by multiplying both the numerator and the denominator by the same expression, but with a plus sign in the middle. Now, remember, the reason that we do this when we have square roots is that this is essentially x minus y and x plus y. And so that means the middle terms with the square roots are going to cancel out, and we're just going to be left with squaring the two values on the end. And so what do we get when we simplify this expression? Well, this expression times this expression is going to be x plus h plus 4. Now, there's a square that because we've multiplied two terms together, but they were originally square rooted. So just to be completely clear about what is happening. Come on, yes, that one. So in the next expression, this will just cancel. And then same thing for the x plus 4. The x plus 4 is being multiplied by another x plus 4, but then that whole squared expression is being square rooted. And the thing in the denominator doesn't do anything. Don't defoil. One of the things that, or don't distribute, one of the things that comes up in these problems is students will sometimes like try to like overdo algebra, and we actually want to cancel that h, so we don't want to distribute it. We want to eliminate it. We do have to do the numerator because we need to simplify, but in the denominator we actually want the h by itself because we want to cancel it. So don't do the distributing in the denominator. All right, so then once we have that expression, then again, I'm gonna, so I don't have to keep retyping. What happens in my numerator is that the square and the square root cancel, and I just have x plus h plus 4. And then the square and my square root cancel, and I have x plus 4. Now it's important to be very careful here because the negative sign goes with both the x and the x plus 4. It's very easy to just cancel the square roots and just write minus x plus 4 without the parentheses, and then it won't cancel the way it needs to. Remember that every expression from the original term is going to have to cancel, and everything that's left is going to have to include an h. That still applies here to our numerator. And now what happens when we cancel? So we distribute the minus sign, minus x minus 4. And so our minus 4 and the positive 4 are going to cancel, and the x and the minus x are going to cancel. And we're going to be left with just the h. So 4 and minus 4, minus x, x, all that's left is the h. And now we can cancel the h's. This h can cancel with this h. And when we do that, we just get 1 in the numerator and this crazy expression in the denominator. And now we can plug in our h equals 0. And when we do that, we can drop the limit because we're applying it. H is 0, makes that disappear. And notice what we have in the denominator now. We have 2 expressions that both are the square root of x plus 4. And so we're left with 1/2 times the square root of x plus 4, which is what we were expecting. So remember, for these square root ones, initially it looks like you're not really going to be able to do much simplifying. Rationalize your numerator, and then you'll be able to cancel. Again, you have to cancel these h's you need to get the h out of the denominator. That is the way that you know that you've done the algebra correctly, is when all the h's in the denominator disappear, so that we can safely plug in h equals 0. And again, all the expressions in your numerator, if you have a more complicated expression, all the terms in your numerator, once you've done your canceling, have to have only h left so that you can do that factoring.